Now, let's start with structural engineers. What do we do? Let's try to recapture what we do in our lives. Well, we model the real world, don't we? We try to model the real world in the best way possible, and we try to make a model which is a multi-material model. It can have steel, it can have concrete, it can have other materials, and we try to make sure that it resembles in the best possible way what the real world scenario will be, so that our analyses are correct. We do analysis after this modeling, and so we create a simplified analysis model which, to the best of our understanding, reflects the actual structure which is going to be built. This is usually done by finite elements, and this model looks a bit different from the real one, but we try to make it as close as possible as far as analysis is concerned, and so that it reflects what the reality is. What we do next is an iterative process. Once we are done with the analysis, an iterative process starts, and we do what we call design. And by this, what we mean is it's the sizing of the various cross sections, the placement of the rebars, the placement of connections. And the reason why I call it an iterative process is that the moment you change a section, the analysis which you did in the previous stage is now obsolete, and it needs to be done again. So this is an iterative process in which we go through several phases of analysis and design, and analysis and design, and finally we get to a point where we're satisfied with the results. At this point, we do the detailing. We actually sit down and do the exact measurements, right down to the closest, right down to the millimeter if needed. And we produce the drawings based on this. And we even create fabrication and constructible information. These days, we're not living in the world of 20, 30 years ago, not even 10 years ago. We are living in a world where everything needs to be modeled the way it's going to be built. And this model then is used for creating fabrication information and constructible information, which people can then use at the site. And of course, when we're dealing with such advanced software, we need to coordinate, because there's not one company which is making a project. There are several companies which are involved. So we coordinate and we share this project information through what is becoming known as the BIM standard, Building Information Model Standard, and we want to convey this information. Now, there's a lot, as you can see, there's modeling, there's analysis, there's design, there's detailing, there's fabrication, there's BIM. So there's a lot which we do. It starts off with the green field, but then it goes through many stages. And it is perhaps for this reason that different companies have developed different softwares for all these stages. So if you were to look around, you would see that there's a modeling and analysis step in this process, and there are softwares which are dedicated to doing just modeling and analysis. So you must have heard of lots of these names like STAAD and SAP and Midas and S-Frame and Robot and ETABS, and there's so many others. Maybe hundreds of other softwares which are available, some more popular than the others. But what I want to emphasize right now, this is one step. This is not the entire process which we as structural engineers and designers have to go through every day. This is just one step of the process, the modeling and analysis part. And then, of course, we have to do the design. And sometimes some of these softwares which I mentioned above, they do take up some of the design steps, but usually it's kind of related to the element design, like the frame element design usually. It doesn't really go beyond that. But then that's not all we do. We do component design as well, don't we? We do, by components, you can think of any specialized part of the structure which needs to be analyzed, which needs to be designed and analyzed as a separate entity. So one example would be your steel connections, for example. And now here again, we see a host of different software which have entered the market, like Procon and Limcon, and all these are for connection design and other components of your structure as well. So once again, we are faced with a host of new software which we have to pay for because the modeling and analysis is done by different softwares. The design is done by different softwares sometimes. The component design is once again done by other softwares. And it doesn't end there, does it? It continues with the detailing and drafting, and here we are faced with other choices. So we are bombarded with all these hundreds of thousands of different softwares we have to choose from and pay for, obviously. So in a detailing world, we now have to produce drawings. So we have AutoCAD, we have BricsCAD, we have so many others. There's no need to mention. But the point being that at every step of the process, our job is not finished. Our building is still unconstructed. Our structure is still in our minds. It's not being finalized. It's not being constructed yet. But we are continuously changing software. We continuously going to these different software providers and producing model after model after model to get to where we want to get to. And then it's not the end yet as well. There's fabrication. There's fabrication literally means you're down to the millimeter now. And here we're talking about very advanced, very expensive software suites like Tekla Structures, Advanced Steel, BoCAD, and this is what we have to go through, unfortunately, every day in our lives. And then there is structural BIM. We have to coordinate with other companies. We have to coordinate with other suppliers. We have to coordinate with other subcontractors. So we use Revit. We use Tekla Structures again. There are other options as well. But what I wanted to emphasize with this slide is that we go through several steps as structural engineers. And there's the modeling, the design, the component design, the detailing, the fabrication, the structural BIM. And for each of these steps, we have to get a software, because obviously we're not living in a world where we do these things by hand. So for the modeling, we have a software. For the design, we have a software. For the detailing, we have a software. For the fabrication, we have a software. And these softwares are usually not compatible with each other, let me emphasize. There are many cases in which a lot of the work has to be redone because although the world is trying to get to a common standard by which these programs can communicate, but that common standard by definition is not proprietary. And if it's not proprietary, what that also implies is that there will be loss of information. So these programs, although they do occasionally speak to each other, but there is loss of information. So there's a lot of work which needs to be redone. And we eventually end up spending many, many more hours than we could have. So this is what we're faced with. Now, modeling and analysis, a software, design, a software, detailing, another software, fabrication, another software. Now, what's happening over here on your right? I'm trying to paint a picture of what Protastructure suite is all about. If you see on the right, I'm going to go through this again, from modeling to design to detailing to fabrication to structural BIM. What if we had all this in one packet? What if all this was done by a single software which took you from greenfield to the finished building, from modeling to analysis to design to detailing to drafting to fabrication to communication of the results with everybody else? That would save us time. That would save us money. And that is what Protastructure is all about.